Hello students, welcome back. So in the last lecture we discussed about what is welding, what are the types of welding, and we discussed just some regarding welding, and that was pertaining to our ISF section, that is Indian Standard Flats, or you can say that rectangular plates. And in that we have seen that we have to discuss two scenarios. The first case or the first scenario was that the weldings are to be applied only at sides, and the second case was that welding is to be applied at end as well as sides. Clear? So in the last sum we discussed about weldings to be applied only at sides. In this lecture we will be discussing that weldings are to be provided at ends also and at sides. Then what will be the change, and we will be discussing angle section, that is ISA section. So moving further, this was the sum that we discussed in the last lecture. The question was design a suitable fillet weld to connect a tie plate 60 x 8 mm to a 12 mm thick GP. The plate is subjected to a load equal to the full strength of member. Assume shop welding and Fe410 plates. So this was our same sum that we discussed the last lecture. The only thing that is changed here is assume side and end weld. In the last lecture we discussed that we had assumed only side welds, and here we are discussing side welds as well as end welds. So the numericals or the answer that we were getting in the previous sum will be the same, which was the first answer, that is LW, we were getting it to be 206.14 mm, that was total length of weld, and we had considered that we had provided welds only at sides, that is no end weld. So we had divided this total length into two parts as we have two sides pertaining to it. So the answer that we are getting on each side was 103.07 mm. The next step was to find our end return, and keep in mind end returns are to be provided only when we are providing welds at sides only. If we are providing at sides and end, then there is no need to provide end returns. So this was our answer, and this was our figure that we discussed in the last lecture, that the side that welds were provided only at sides. Now what will change in this figure, or what will change in this sum? So moving on to today's sum, the total length that was acquired in the previous sum will be the same, that is 206.14. so the figure will be the same as you can see here. The only change is we need to accompany this height. That means this height is to be completely fulfilled by weld, and as we know that total length of weld is 206.14, and the height that to be accompanied or height that to be filled by weld is, as we can see, as 60 mm. Why so? Because the width of plate is given in the question. So as we are doing end welds, it is mandatory to provide our weld at ends, and as we know that the total length of end will be the width of plate, which comes out to be 60. So the total length was 206.14, and we have to mandatory provide our end, that is 60. So the remaining length will be 146.14 mm. Clear? And this weld is to be divided into these two parts, that is the upper portion and the lower portion, or you can say upper side and lower side. So now we will be dividing this length, that is 146.14, that is the remaining length, divided by 2, as we are providing on both sides as well, and the answer that comes out is 73.07 on both sides. Clear? So on both sides we are welding up to 73.07 mm, and we are completely welding the end, that is 60 mm, and the lower end again 73.07 mm. So total length again will be the same. So in both the criteria that we have discussed in the last lecture and we have discussed now, the total length will be the same. The only thing is that is changed is how are you designing it. There can be two conditions, as we have seen. The first condition was we discussed in the last lecture, that was the weldings are to be provided only at sides. That was our first case, and this is our second case, that is weldings is to be provided at end as well as sides. Clear? So this is the basic difference. In question it may be given or it may not be given. If it is given, to follow the proper instruction, as we can see that here it is mentioned in question as assume side and end weld. But in the question or in your GT examination, if it is not given, then you can assume any of the both scenarios. Okay? So moving on to the next sum today, the question is pertaining to ISA, that is in Indian Standard Angles, and the question here is an ISA 125 x 75 x 8, again we are describing what are the basic concepts that we use in the bolted connections. We are just refurbishing that stuffs, and the size, as we can see, is 125 cross 75 cross 8. That means the longer leg is 125 mm, the shorter leg, or you can say the outstand leg, will be 75 mm, and the thickness of both legs will be 8 mm. It is prescribed as per our IS standards, and it is connected to a 8 mm thick GP. GP, that is our gusset plate. We had discussed gusset plate in the previous chapter. The same phenomenon or the same fundas are to be applied here also. So in this case, only one angle is to be provided of IS 125 cross 75 cross 8, which is connected to a 8 mm thick GP. Yeah? And it is also mentioned that the longer leg is connected to the GP. Yeah? That means the 125 mm, the longer leg, will be connected to GP, and the outstand leg will be 75 mm in this case. And here in this sum, it is also given that it is connected by a 4 mm size weld. Clear? So capital S, or you can say size of weld, that we have calculated in the previous sum, we don't have to calculate again here, as it is given already the question that S is to be taken as 4 mm. Clear? So moving further, it is said that it is to transfer an axial pull, that is axial tension, of 120 kilonewton. 120 kilonewton axial load it is to be transferred, and we need to design the welded connection and show the details by sketch, that is what weld have you provided and what up to the certain length you have provided the weld. And it is been asked that assume shop welding. We have two criteria in this. The first is shop welding, the other is field welding, and it is mentioned that welds are to be provided only at sites. Clear? So now moving on to the figure. Here will be the angle section. As you can see, it is the side view or cross sectional view, and the longitudinal view on the right hand side of the screen, and the cross sectional view on the left hand side of the screen. Both angles can be seen here. The first, that is the vertical length, will be our longer leg, and the horizontal leg will be our shorter leg. Same way in the longitudinal view too. Okay? And it is connected to a gusset plate. It is connected to gusset plate, as you can see here. So the gusset plate of 8 mm thickness is being seen. Clear? Now what to do? The dimensions are be given as 125 mm the longer leg, 75 mm the shorter leg, and the thickness will be 8 mm. Here the plate thickness, that is the gusset plate thickness, is also 8 mm, and the angle thickness is also 8 mm. Now how this question differs from the sum that we have seen earlier. Keep in mind, the earlier sum was for plate section or rectangular plate, and as we all know that the CG of rectangle is always at its center, and the dimensions are b by 2 and d by 2. Again, keep in mind, the CG of a rectangle is always at its center, having dimensions from origin as b by 2 and d by 2. Clear? And as the dimensions are half, we are dividing the total length into two parts. That is, the upper side will be getting the half of the length, and the lower side will be getting the half of the length. Again, why? Because the axial pull is applied at its CG, and CG of a rectangular plate always belongs to its center point or midpoint. Clear? Here we are dealing with an angle section, and CG of angle section is never at its midpoint, or you can say never at its b by 2 length or d by 2 length. So as you can see, we need to provide two different sides, or we need to provide welds on two different sides, but this length won't be directly half. Why so? Because the CG is not at its center. So the first thing here will be to find the CG. So take an arbitrary axis. So we need to find the depth, or we need to find the height of this axis, and on this axis, this will be our neutral axis, and on this axis the total axial load will be acting upon. So how to find this? For this we need to move on up to our steel table. So moving on to our steel table, page number 8, this will be our first case that will be referring this page, and in the later on sums or the later on chapters we will be referring this type of pages in numerous times. So keep a note of it, how to rectify or how to identify this page. As you can see in the figure that is on left top corner, it shows of angle section. Clear? The figure itself shows of angle section, and you can also see the title of this page, that is rolled steel unequal angles. Keep in mind, here we are dealing with two types, that is equal angles and unequal angles. Clear? Here, as you can see in the question, it is mentioned 125 cross 75. That means we are dealing with unequal angles. So you need to refer the page that contains unequal angles. In the first column, you can see the ISA nomenclature being mentioned. Clear? There you need to identify where 125 cross 75 has been mentioned. So you can see in this page that 125 cross 75 is been mentioned here. And in the next column, the thickness of this and legs are being given. So as you can see that in the second row here, in the section that is 125 cross 75, then in the second row, in the second column, it is mentioned that 8 mm thickness of leg is given. So we need to refer this whole row. Clear? So moving on, we need to refer this row. Clear? And where to look upon? There in the columns you can see here that center of gravity is being mentioned. Clear? And pertaining to that, two rows are being identified. The first one is CXX and the second one is CYY. That is center of gravity across XX axis and center of gravity across YY axis. And as we have discussed in the previous figure, that we are dealing with the XX axis only. Why so? Because the force that is applied is axial pull. Clear? The force that is applied on our angle is axial pull, that is belongs to XS axis. So we are always taking CXX value. So as you can see here, the CXX value will be 41.5 mm. Here it is mentioned 4.15, but keep in mind the title, it is centimeter. Clear? So as it is in centimeter, we need to convert it into mm. That becomes 41.5. Clear? So moving further, here you can see that the cross section is being given and the dimensions, that is our CG, will be 41.5 mm. Clear? So how to move to the sum now? As you can see, the ISA section is given 125 cross 75 cross 8, and we have identified CXX, that is 41.5, and the size of weld is already given in the question. So as you can see in the question, the size of weld is 4 mm. So from the size of weld, we always will be calculating the throat thickness. Clear? And throat thickness, that is TT, will be always equal to 0.7 into S. And calculating that, the value comes out to be 2.8 mm. Clear? So after TT, the second step will be to find FWD. And keep in mind, for shop welding, FWD will always be 189 Newton per mm square. And why so? For that we need to refer code, and we need to refer this 10.5.7 clause. We have seen in the last lecture, the same things have to be applied. So solving these equations, we will be getting FWD equal to 189 Newton per mm square. Clear? So the first thing that is identified is TT, that is throat thickness. The second thing that is to be identified is the FWD, that is our stress. Clear? So moving forward, we will be considering, or we will be finding the length of weld, and for that we need to consider fillet weld. Clear? Here in the question it is not mentioned that which type of weld to use, so we are using fillet weld in this case. As you can see in the figure, the CG of the CG of our section, which will be at 41.5 mm. Now keep in mind, the 120 kilonewton load will be acting at its CG. Clear? And as it is not a symmetric section, because it is not a rectangular plate, the sides or the length of weld will not be directly divided by 2. So how to find that? For that we will be taking two reference points. Let us take reference point A at the top end of the plate and reference point B at the bottom end of the plate. Now what to do? Now we need to assume forces. So let us check P1 force to be applied at the point A and P2 force to be applied at point B. So we need to find these two forces, that is P1 and P2. Now keep in mind what to do when ISA sections are given. So the total load that was acting on the section was 120 kilonewton. But 120 kilonewton, as it is not in the center of the plate, so the length of weld won't be directly considered to be half. So we need to find how much load is applied at which side. So taking the upper side, we have assumed a point A, and the force that is acting at point A, we have considered it to be P1, and pertaining to the bottom side, we have taken a point B, and the force pertaining to this point B, we have assumed to be P2. So we need to find these forces that are P1 and P2. So from P1, we could identify the LW1, that will be length of weld on the upper part, and from P2, we could identify the length of weld on the bottom part. Clear? So this way you will be always identifying the length of welds when the symmetric sections are not given in the question. Clear? Now how to find these loads? For that we just need to do basic moment equations. Clear? We just need to take basic moments. You can either take moment at A or moment at B. There is no issue in this case. I have taken moment at B. So as I have taken moment at B, the force P2 will be equal to 0. Why so? Because P2's line of action will be coinciding with the point B. Clear? Again, P2's line of action will be coinciding with the point B. So the vertical distance will be 0, and as we all know that moment is equal to force into perpendicular distance, and so perpendicular distance will be 0, so P2 will be 0. So now we will be dealing with only two forces, that is P1, that is applying on point number A, and 120, that is in the right hand side of your figure. Clear? So you can see here that P1 into the distance, so the distance between point A and B will be the total longer leg. Clear? Again, the distance between the point A and B will be our total longer leg. So P1 into 125, which will generate an anti-clockwise moment at point B. Clear? That will generate an anti-clockwise moment at point B. So we are equating anti-clockwise on one side and keeping all the clockwise moments on the other side. So now the 120 kilonewton load, this one keep in mind the right sided load, that moment, that force will apply a moment that is of clockwise nature onto point B. So the moment of the right hand side force will be 120 into 41.5. Clear? So from this we can calculate the value of P1, which comes out to be 39.84. Now how to calculate P2? We will do simple basic equilibrium conditions. As we all know that the total force will be acting in one direction, and we are just bifurcating it into two parts. So you can assume, or you can think that what about the left hand side force? Keep in mind it is only one force. One force or a one axial force of 120 kilonewton is applied. So if you are taking the right hand side force 120, then left hand side won't be considering. Clear? This is just an example of axial pull. So you don't need to consider both the arrows in this case. Clear? So if you are considering the right hand side arrow, left hand side arrow won't be in the picture. So now how to find this P2 force? We will be just applying equilibrium conditions. As we all know that the total load will be in the right hand side, so it will be the sum of the forces that is acting in the left hand side. So P will be equal to P1 plus P2. As we all know, the P is equal to 120 kilonewton, and P1 we have already calculated it to be 39.84. So P2 in this case comes out to be 80.16 kilonewton. Now we have calculated the values of P1 and P2. From these values, we always need to identify length of weld 1, that is LW1 and LW2. So from the force P1, again applying the same equation, that is P1 equal to LW1 TT FWD. TT will be the throw thickness, FWD will be our stress component. Clear? So the unknown will only be LW1. So from P1 or pertaining to P1, we will be calculating LW1, which comes out to be 75.28 mm. Clear? And from P2, we will be calculating LW2. So this will be our length of weld on upper part and length of weld on lower part. Now how to mention in it figure? But keep in mind one thing is remaining. As we have provided the welds only at sides, so it is mandatory for us to provide end returns. Clear? So in this case, as the size of weld is 4, so the end return will be 2 into 4, that is 8 mm. Clear? So now the total length or total LW1 will be 75.28 plus end return, that is 8, which comes out to be 83.28. Rounding it off, we get 85 mm. And similarly, LW2 we get, after rounding it off, to be 160 mm. So this will be our final length on upper side and lower side. Now how to describe it in figure? This was our figure that we have plotted, and this will be our both sides weld, that this will be our welds that we have provided on the both sides. And considering the dimensions, this will be our 77 mm dimension that will be on the upper part, and again the 8 mm end return we have provided, and similarly on the bottom side we have provided this dimension. So figure, as you can see, it is mandatory in the question. Even if it is not asked, you have to compulsory write or compulsory draw figure in the question. It carries 1 mark. Clear? So this was our sum regarding angle section, and this is today's exercise problem. Solve it, as we have seen angle sections for the first time, and we will see furthermore sums in the next lecture. Okay, thank you.